Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network, coming to you from a hotel in London, ramshackle setup, but never mind, the show must go on. Today's topic is food safety with hygienically constructed equipment built to sanitary design. And today's guest speaker is Mike Evans from Eagle. Good morning, Mike. How are you doing?
Good. How are you?
I'm fine. First time with us, and we've got 1,455 registered, so we're looking forward to a good topic.
Okay.
Where are you joining us from today, Mike?
Beautiful Tampa, Florida.
Beautiful. And I'm like I say, not in Manchester today. I'm in sunny London. Let us know where you're joining from in the sidebar. It's always good to know. Narelle's from San Diego. Nicola from Trinidad. Who else have we got? Mo Jarhead from KSA. Wherever you're from, you're very welcome. We're going to play the sponsors ads now. We'll be back in a couple of minutes for the presentation.
Food safety accidents are a real possibility these days, meaning an increased scrutiny and rigorous testing on production and other areas. From farmland to dining tables, each stage of the entire food supply chain is challenged by product safety, quality, and effectiveness. Whether you're a grower, food packer, trader, or hold any important role in the food supply chain, HQTS can help you to ensure quality and safety from the source. Our services include product inspections, safety audits, quality management, and consulting and training. HQTS, your partner in quality.
Okay, final ad there from Eagle, one of our kind sponsors of Food Safety Fridays, and fitting as today's presentation is from Mike Evans from Eagle. Okay, it's all yours, Mike. I'll be back for the Q&A later, but for now, hand you over to Mike.
All right. Thanks, Simon. Hello, everyone. I'm here to talk about sanitary design. It's a topic that I've dealt with quite a bit over the years. I work for Eagle Product Inspection, who is a manufacturer of X-ray equipment used in the widely used in the meat and poultry industry, as well as other food industries. Over the past several years, we've put a significant amount of effort into continuously improving the hygienic design of our equipment. So I've become very familiar with a lot of the standards associated with that. Food industry as a whole, I've been involved in for about 20 years, and actually have a degree in engineering from the early 90s from Penn State University. At that point in time, if someone had told me that I'd be doing a webinar on hygienic design, I'd probably first say, what's a webinar? And then say, what's hygienic design? So that rolls us right into the next slide. The agenda we're going to go through today is, first, what is hygienic design? Also, why is it so critical? We'll talk a little bit about who sets the standard for hygienic design. And then we'll go through the 10 principles that are set forth by the North American Meat Institute. And then hopefully when we're done, we'll have some time for questions and answers. So the first big question is, what is hygienic design? And the way I see it is hygienic design is designing a product and building a product in such a way that it doesn't contribute or increase the risk of microbiological hazards when this thing is installed into a processing line. So ultimately, it wouldn't increase the risk at all, but just by virtue of putting a piece of equipment in line, we're going to increase the risk some. So what we want to do is minimize the amount that we increase the risk. And there's a few ways of doing that can have a big effect. It really needs to be easy to clean. And the standards really do a good job of laying out how you accomplish that. It also needs to be easy to sanitize and easy to inspect. And one very important aspect of machines in this environment is that they need to be able to hold up to the environment. In the meat and poultry industry, the washdown process is very rigorous, uses high pressure, high temperature water, along with cleaning chemicals that are fairly caustic. In addition to that, sanitation chemicals. And then in the end, the machine needs to be easy to inspect by the people that give you permission to go ahead and start production. So why is hygienic design so important? First of all, there's significant human costs associated with foodborne illnesses. About 1 in 6 people in the United States get sick every year, and it's estimated that over 3,000 people die annually in the U.S. So, that's a significant number, and I certainly don't want to be associated with or feeling like I did something that contributed to someone dying or even getting someone sick, and I'm sure that most other people feel the same way. But to go along with that, there's significant financial costs also. It's estimated approximately 15 million pounds of product were recalled in 2021, and that's a significant cost to go along with that. It's estimated that about every recall costs about $10 million, which is a very significant amount of money for our processors. It goes right to the bottom line. And a good hygienic design can have a strong effect on minimizing these risks. So there's a lot of standards available for guiding us through the hygienic design process. And fortunately, they're all very similar. Most of them are from Europe and the United States. The first one that I have listed here is CE, who addresses sanitary design in the machine directive, and also has some European norms associated with hygienic design. Most recent one is from 2020, which is a very good standard. I think it'll be becoming much more prevalent in a short period of time here. You also have EHEDGE. EHEDGE is an agency in Europe that actually sets standards for hygienic design and also certifies equipment for hygienic design. Here in the United States, we have the FDA. The FDA has a big effect on the materials that we can use for food contact. Also has the USDA under their umbrella. And the USDA actually has federal inspectors in every meat and poultry plant here in the US. And they have a lot of say-so on what goes on as far as the equipment's used. They have the ability to prevent production from starting if they're not happy with the condition of everything after sanitation's finished, or if they're concerned about a piece of equipment in the line. We have the North American Meat Institute, which is developed the 10 standards we'll be looking at in this presentation. They are made up of industry experts, and their most recent version of their standards came out in 2021. We have the National Sanitation Foundation. They also set standards and certify equipment, and the North American Meat Institute actually references a lot of their standards in their guidelines. The one that I don't have here is 3A Dairy. The reason I didn't list it is because this is really focused around the meat and poultry industry. But with that said, the 3A Dairy standards are fairly similar to most of the standards we have listed here, a little bit more stringent. But if you were to adhere to the 3A Dairy standards, you would be in pretty good shape relative to compliance with these other standards. So now we get into the principles of sanitary design. I have the 10 NAMI principles listed here. We'll go through the slides and hit on each one of these. Under each principle, there's several different guidelines that they have listed. We're not going to touch on all of them, but I'm really going to focus on the ones that I feel have had the most impact on our equipment designs here at Eagle. So the first is the equipment needs to be cleanable to a microbiological level. The equipment has to be constructed in such a way that it's easy to clean. If it's not easy to clean, then it's less likely to get cleaned or much more difficult to remove all of the potential hazards. The surfaces really need to be accessible for mechanical cleaning, mostly so they can be easily sprayed down during the wash down process without getting in there with a lot of other tools or brushes or anything to accomplish it. You really just want to be able to hit it with a high pressure spray and get all the contaminants off the equipment. And you also want it to be clean. You want to be able to tell if it's clean based on sight, touch, and smell. You want to be able to look at it. You want to be able to see all surfaces, so you can see if there's anything left in there. If you touch it, you want to be sure that there's nothing slimy or greasy on the surface. And then obviously, if you smell something bad, there's probably something somewhere that needs to be removed. Next is the equipment needs to be made of compatible materials. Materials need to be corrosion resistant, non-toxic, and non-absorbent. And these are requirements that are set forth by the FDA for food contact. And one of the most common materials for this environment is 300 series stainless. 300 series stainless has very good corrosion resistance. 304 being the most common. When you go into meat and poultry plants, you see a lot of 300 series stainless around. For plastics, very common plastics are UHMW, HDPE, and acetyl. These chemicals all have good mechanical properties and hold up well to the chemical exposure that we encounter in these environments. When it comes to belting, for seamless belting, polyurethane works very well. Some of the polyurethane belting does have reinforcement in it and may require some edge sealing or something to that effect to make sure that the reinforcement is not exposed, or it needs to be cut in such a way that the reinforcement doesn't get exposed when it's cut. One of the things we really want to avoid is coatings, platings or paint, that sort of thing. It tends to chip off and it can get in the food. So this is something that we really want to avoid when it comes to hygienic design. And all this stuff again needs to be able to withstand the exposure to the cleaning and sanitation chemicals. A lot of caustic and acidic chemicals here that can have some detrimental effects on the components if they're not made out of the right materials. So everything also needs to be very accessible for inspection, maintenance, cleaning, sanitation. Okay, so the surfaces should be readily accessible. Ultimately, it shouldn't require any tools to disassemble the equipment. With X-ray, there is an FDA requirement that a tool has to be required to open it up for radiological safety. So that kind of trumps this standard, but nevertheless, it's just a flathead screwdriver that's required, and it's quick and easy. And you can see in the photo on the right here, they're removing the belt. This particular machine can be broke down for the washdown process in about 3 minutes or so. So it's fairly quick and fairly easy. You also want to have a storage location for your COP parts. These are the parts that you remove for cleaning. Obviously don't want to leave them laying around on the floor where they can get damaged or dirty and become unsanitary. So, the customer should either have some kind of rack for the parts or a parts cart can be purchased. Belt tension should be easily removed. You can see in the picture on the right, there's a small mechanism on the right-hand side of the conveyor where really all you need to do is pull a lever and that removes the tension in the belt. And after that, the belt can be easily removed. We want to have 12 inches of floor clearance under the machine, so it's easy to wash under the machine. And also, air hoses and vacuum hoses need to be transparent. So if there is some mold or bacteria or something to that effect growing in there, then it'll be visually apparent that there's some contamination that needs to be taken care of. Principle number 4 is we don't want to have any liquid collection on the equipment. You can see in the photo of the machine on the right that there's very few flat surfaces. Even the surfaces that look close to flat have a few degrees of draft on them, and this prevents water from pooling up there. Some of the other surfaces, for example, the framework, are at an even steeper angle, and the primary reason for this is to prevent product from building up on there when it drops from the food zone. And one other very important aspect is that we don't want any of the parts to be able to drip, drain, or draw product into the product zones. So basically any parts that are above the product zone need to be of hygienic design, or they need to prevent the product from getting to the product zone. Principle number 5 is hollow areas should be eliminated or hermetically sealed. Best case, we eliminate the hollow sections. We really want to avoid the use of hollow sections whenever possible, and don't use them unless they're absolutely necessary. The reason for this is, the hollow sections, even if they're hermetically sealed, it's possible, through welding or whatever process, that the seal isn't perfect, and then through the thermal cycling that goes on in the plant during washdown and production, it draws air in, pushes air back out, and along with that air can be water or bacteria or whatever other contaminants cause problems. And it also creates an area where bacteria can grow because there's no way to get in there to clean it or to do anything to stop it from growing. So, when air does get pushed back out, it pushes some of that nasty stuff back out with it, and potentially contaminates the food. And if you do have any hollow tubes, you obviously don't want to have any fastener penetrations into there because, the same reason, it creates a path for the microbes to get inside. And Another common setup for leg adjustments that we need to avoid is having a vertical tube where the leg threads into the bottom. You can see with the picture of the threaded leg adjustment we have at the bottom here, it's all external, so it's all exposed and it can be easily cleaned. Principle number 6 is no niches. All of the standards have a surface finish requirement for hygienic products, and they're all the 32 micro-inch RA for the food contact surfaces. This is 0.8 micrometers RA for metric. Those numbers match up identically when you do the conversion. And then for the non-contact surfaces, it's 125 micro-inch, so it's a little more coarse, but nevertheless, there's still a requirement there. The welds need to be continuous and smooth. We don't want to have any pinholes or inclusions where bacteria can get in there and we can't clean it out. Internal corners need to have a minimum 1/8 inch internal radius, and this is so food cannot get stuck into those corners and prevent it from being easily cleaned out during the washdown process. And another very important part of this principle is that fasteners should not be used in or above the product zone. The standards do actually allow for use of fasteners in the product zone, but it's preferred that it's avoided for a couple of reasons. One is, first of all, fasteners can fall out and get into the product. So if you do have a fastener in there, you need to have some kind of locking mechanism to make sure that it won't fall out. And then in addition to that, you have a contact surface between the head of the fastener and whatever it's fastening that creates a place that can't be cleaned and we can harbor microbes. So if there are fasteners in the food zone, that area needs to be sealed. What we have found is that the best thing to do is try to avoid it altogether, because in general, the sealing is fairly expensive and has to be replaced periodically because the elastomers over time end up deteriorating due to the chemical exposure. So, again, the best thing to do is try to avoid using fasteners altogether in or above the product zone. Principle number 7, operational performance. We want to keep the control panel in a place where it's not above the product zone. The control panel, it's getting touched and it's getting dirty, and we don't want any liquids to be able to run from the control panel and drip into the product zone. So we don't want to have it directly above it. We don't want to use compressed air on products unless it's dried and filtered. There's some fairly stringent filtering requirements if you want to have compressed air actually contacting unpackaged product. We want to keep motors and bearings outside of the product zone. The bearings, just because of their nature, are not as hygienic as we'd like them to be for something that we use in the product zone. And the same goes for the motors. So you can see in the picture on the left that we have the motor outside the product zone with a few inches between it and the belt, and then also a barrier in between. And then also the equipment should be built to minimize product buildup. Try to avoid flat horizontal surfaces wherever you can. The hygienic design of maintenance closures is very important. We don't want to have maintenance enclosure in or above the product zone. One very important point here is that they need to be able to withstand the washdown environment. When it comes to enclosures, we frequently talk about the IP rating or the ingress protection rating. IP69 is kind of the gold standard with IP ratings. I think when it comes to hygienic design, it's kind of a starting point with some equipment that maybe doesn't get hit as hard during the washdown process, an IP69 rating may be sufficient. In my experience, the products that get hit hard with washdown, you need an additional level of protection above and beyond what IP69 provides. The IP69 test requires the spray nozzle for the water to be 4 to 6 inches away from whatever surface you're testing. And what we found in the meat and poultry plants, primarily in the US, is that they'll get right on the surfaces that you're trying to seal up. And when you're doing testing for IP69 or for ingress protection, you really want to get the nozzle right on those surfaces and make sure that you don't get any penetration inside the cabinet. IP69, it's a good rating, but I think most of the people that have spent quite a bit of time in the meat and poultry plants will agree that it's not quite sufficient in a lot of cases. Conduit should be at least 12 inches from the floor. This is to make it easy to clean underneath it. And we also want to avoid the bundling of cables, because that creates areas between cables that are hard to clean. Principle number 9 is compatibility with other plant systems. We want to make sure that the pneumatics are not exhausting into the food zone, because the air can be contaminated. We want to make sure that the fan cooled motors are not blowing air toward the product zone, because again, that air can be contaminated. You can see in the picture to the right that we have the motor outside of the food zone and a barrier in between that prevents the air from transferring in that direction. Any specific biological risks associated with the piece of equipment should be identified, so the plant knows that they need to pay special attention to that area. And we also want to make sure that ducts drain away from the product zone. We don't want to have any contaminated water dripping into the product zone. Another thing is AC units. This particular machine you see in the picture has an AC unit on the back, and the AC unit exhausts in a direction that's pointed away from the product zone. We also need to validate the cleaning and sanitizing protocols. First of all, the sanitary design process really needs to start in the beginning of the development process with the equipment. What we found is that when you address this early on in the development process, it's a lot easier to accomplish your objective with the design than it is when you consider it later on and have to try to make concepts work that are already kind of settled, such as getting fasteners outside the food zone. If you start from the beginning saying we're not going to have any fasteners in the food zone, it's a lot easier to accomplish when you start when you start thinking about it when you're 3/4 of the way through the design. Sanitation procedures need to be provided, and those are typically provided in the user manual for the machine. And again, all the components need to be capable of withstanding the sanitation process. So, in conclusion, hygienic design can have a huge impact on consumers and processors in avoiding and preventing people from getting sick. It needs to be considered at the very beginning of the design process when you want to develop a piece of equipment used in this environment. All the worldwide standards, they're very similar. Designing for one of the standards probably puts you in pretty good shape for compliance with the rest of the standards. But if you are developing global equipment, you want to consider all of the standards early on to make sure that you're in compliance with all of them. And finally, designer for the environment, particularly the washdown environment and the exposure to the cleaning and sanitation chemicals is very important for the machine. If it's not designed for that, the machine's going to end up creating a lot of problems for everybody, not only for the customer in the form of downtime, but also for the manufacturer in terms of warranty and reputation. So we really want to make sure that we do a good job of designing it for this environment. And that is all I have for the presentation. So now we have some time for questions and answers.
That's great, Mike. Thank you very much. If you can switch your webcam back on, and then we'll get to the questions. Yeah, it was really great. That lots of.
Thank you.
Yeah, let me just get rid of those. Yeah, lots of great practical tips, and along with the photographs that highlight it even more. So excellent, and often overlook things. So yeah, if you have a question for Mike, please type it in the chat bar and we'll get to it. Just the first one from Karen. Yes, we will be circulating the presentation afterwards. So an hour or two after the webinar concludes, we'll send an email to everybody with the recording, the slides and the certificate. So yes, don't worry about that. Let's see now. Yeah. Question from Barbara. You call it we call it a niche, or niche, a niche or a niche. What is a niche?
It'd be a very small area. For an example, on a surface, when it comes to surface finish, you have, if you look at it with a microscope, you see kind of peaks and valleys, right? So the niche, or whatever, however we want to pronounce it, would be the area down in that valley that's very hard to clean.
Yeah, it's in the same category as nooks and crannies, all the hard to reach areas and things like that. Okay, so a question from Anup. Are the specification of no inch slide, is that the same for all food processing plants?
Yeah, I'm not sure what no inch slide means. Is it possible to get some clarification on that?
Yeah, if you can just expand on that a bit, Anup, then we'll try and address that one for you. BG Raguma said, what about addressing lubricants? Is that within the scope of this presentation or not?
Yes, actually, for bearings, right? A lot of the machines have bearings on them, and you want to make sure that you use a good food grade grease. So, the food grade grease, if it does get in with the food, it's not going to make anybody sick. They obviously want to avoid that, but good food grade grease should take care of it.
Yeah. Question from Nicholas. I am the food defense technician at a smaller honey processing plant. How would you say this would translate to us? So does food defense have any bearing on the design of equipment or not?
Well, yeah, I guess I'm not exactly sure what food defense is, but I'd say when it comes to honey, hygienic design would definitely be very important. And the reason is that, honey does not have an additional processing step before someone eats it, right? Yeah. So a lot of foods, even meat and poultry, most of the time we cook it. So even if there are some, microbiological contaminants in the meat and poultry, we can kill that all off when we cook it, right? But with honey, if you're just eating raw honey, that's not the case. And you have similar situation with dairy products. In fact, that's one of the reasons that the 3A dairy standards are a little bit more stringent than the ones we see in the meat industry, because you have dairy products that are, contacting the equipment, and then there's no intervention step afterward to kill anything off. So it really needs to be extremely hygienic.
Yeah, get that. Question from James. Is there a requirement wherein COP parts should be in a soaking solution?
Yeah, I'd say that's dependent on the part, right? So there was something in there about any special requirements should be identified. So if there's something about this part that makes it particularly hard to clean, let's say, for example, you can't adhere to the standard where you have an 1/8 inch internal radius, right? You know, if you were to take that part and soak it in a solution, uh, there's a good chance that it would get out all the stuff that you can't with just normal wash down.
Okay. Question from Jennifer. What's your experience of coordinating with quality teams on design, best practice, etc.?
Yeah. Okay. So in the design, you obviously want to have good specification for all the parts, and things like the surface finish and the internal radius and the welds and everything. You should have enough detail around those that the manufacturing people can produce a good part that'll meet your needs in the end. And quality is part of all that.
Okay, yeah. Question from Erica. Do you have a suggestion on sanitizing materials?
I don't have a suggestion. What I can say is there's a lot of them out there. It seems like every food plant that I visit is using something different. So I think there's a lot of good data out there on the internet where you can do some research. I'd encourage you to contact the manufacturers of the sanitizing chemicals and see what they recommend. But yeah, I don't have any specific recommendation there.
Okay. Rajneesh, are these 10 principles applied to all food equipment?
No. Particularly unpackaged product is where we need to adhere to these principles. At Eagle, we make machines for inspecting packaged product also, and we do not adhere to those principles with the machines for packaged equipment. And part of the reason is, to do a really good hygienic design, unfortunately, it's going to add some cost in most cases. So we don't want to add that cost to the machines where it's not necessary.
Okay. I've just, he calls, or they call a niche a sanitary trap. So
okay,
there's another
like
term for it. Yeah. Sherelle, when looking to source new equipment, is the best way to weed out suppliers? Should you look for the certifications that you initially mentioned?
Yeah, okay. If someone has a certification, one of those standards, then that's great. But I think what you're going to find is that most of the equipment doesn't have certifications. So even the North American Meat Institute guidelines, those are guidelines. So no one's going to certify you to the guidelines.
Yeah.
There are some certifying bodies out there like EH, NSF. So if an equipment has that mark on it, then great. That's going to say, yeah, it's good and hygienic. But I think what you're going to find is the majority of the equipment out there doesn't.
Okay. Sabina, very good presentation. I'm in the dairy industry. Would the measurements of the niches slide apply?
Yeah, so absolutely. This is even more critical in the dairy industry because, again, there's no intervention step in most cases after the food contacts the equipment. So I believe the surface finish requirements for 3/8 dairy are the same, the 32 micro-inch RA, but they absolutely apply.
Okay. Question from Braulio. Is there any manual with the standard specs that equipment need to have?
Yeah, I'd recommend that you do a quick search on the internet for the North American Meat Institute guidelines. It's very easy to find, and it's free. It doesn't cost anything. And along with those guidelines, they have a checklist where you can actually score the equipment and give it a hygienic score. Okay. So it's a very good tool.
Can you just repeat the name of that, Mike?
North American Meat Institute Hygienic Design Guidelines.
Okay, thanks. Moja Head, could you list the stainless steel food contact specifications and other food contact specifications?
Okay, so most of the standards want to see 300 series stainless minimum. Unless there's some reason that you need to use some other grade. For example, in grinders and some of the stuff where you need a really hard grade of stainless. It's probably a 400 series and doesn't have quite the corrosion resistance to go along with it. So, it might require some different processes for cleaning and sanitation also. But 300 series is the key. In most cases, 304 is sufficient. Sometimes you get into situations where you want to use a 316, like more corrosive environments where there's a lot of salt exposure, potentially with seafood.
Okay, thank you. Question from James. I told you there'd be a lot of questions, didn't I, Mike?
Yeah, hey, this is good.
Yeah, testing your knowledge here. James, is there a requirement wherein COP parts should be in a soaking solution?
I think we had a similar question earlier.
Yeah.
It's not a requirement. Unless there's something special about the part where, say, for example, it doesn't adhere to all the guidelines and you need to do some special processing to get it sanitized or clean and sanitized. But in most cases, with the Eagle machines, you remove the parts, you hang them somewhere on a rack or a parts cart, and you put those through the same sanitation process as everything else.
Okay, thanks. Question from Badmos. What advice can you give an existing poultry processing plant with a poor design to ensure safe products?
Well, I'd say it's probably going to require a lot more attention during the cleaning and sanitation process, and also a higher level of scrutiny when it comes to inspection.
Yeah. Ricardo, it's not a question, this, he just comments, it's also important to remark that anytime you have equipment that has rotating parts with different materials, it's a big risk of contamination and they should be easily to disassemble. That was just a comment. Question from Supriya. Wants to know whether dusty environments affects X-ray machine performance. What type of cleaning is recommended for a dusty environment? A little bit off scope, but any?
Yeah, dust can affect it. Part of IP69 certification is that it's also dust proof. That's what the 6 means in IP69. So, that'll prevent dust from getting inside the machine, but if the machine has an air conditioning unit on it, the dust can affect the performance of the air conditioning unit and cause it to, either fail prematurely or cause the machine to overheat, which is a problem.
Okay. Question from Anup. In your perspective, what will be the future design and challenges of food processing plants? Have you any particular views on that?
Well, the best plants that I've seen are the ones that build around the process, compared to a plant where someone's the building already exists and they're trying to fit a processing line into it. So the new plants you see, they do a really nice job of accommodating the sanitation process and make sure that everything's going to be easy to clean and maintain. So I'd expect to see more in that direction, along with just more attention to sanitary design in general. It seems to be getting an increased amount of attention on a regular basis.
Yeah, as can be seen from, you know, almost 1,500 people registered for this webinar. It's a growing demand and a growing topic of interest for sure. Question from George. In a batch dryer to dry banana chips, hot air is used directly to dry the food. What would be the best way of meeting sanitary design of the dryer?
Yeah, so if you're drawing in outside air to to dry the chips, I think that air would need to be filtered to a very fine level. I think the standard is somewhere around 0.3 microns or something to that effect.
Okay. And Ricardo, just a comment. This is a great step to include sanitary design in all food industry. Great presentation. Question from Christian. What would be the best practice when it comes to commissioning an equipment from a sanitation perspective?
Yeah, well, in the U.S., the USDA has a big say in that. So when you put a new piece of equipment in a meat or a poultry processing line, the USDA people that work at the plant are going to take a close look at it and make sure that they're happy with it from a sanitary design standpoint. And that's one of the reasons you want to make sure you adhere to these standards before you put it there. The USDA knows a lot about this. In fact, the USDA, until about probably 20 years ago or so, they used to actually certify equipment. So they understand sanitary design very well. And when they're looking at this equipment to commission it, they know exactly what to look for.
Okay. Eric is asking, can you write down the name of the guideline mentioned? Cassandra did write it down. I'll copy and paste it in the chat again. There it is, the NAMI Hygienic Design Guidelines. So if you Google that.
Very easy to find.
Yeah. Okay. Oh, it's a bit of a funny one. Well, to me anyway. Shiva, can we design a food processing plant which is entirely floating on a water body?
Yeah, I mean, it's funny you ask that. A lot of the tips for processing fish are basically a food plant on the water. They catch the fish and just run them through the processing plant and, have patties or fillets of fish stored in trays, and they just unload that stuff when they get back to shore. So I'd say yes.
Okay. Any further questions? Just Mohammed, my first online course, I got everything from you. Many thanks for you. The presentation is awesome and fulfilled everything. And fulfilled everything. That's a dream recommendation there for you, Mike.
Much appreciated.
Okay, there's a bit of a chat going on about honey in the chat about further processing or honey that is just harvested and jarred. But anyway, Simba, do you foresee hygienic design guidelines becoming regulations or auditable standards at some stage?
Yeah, I'd say they are already regulations in Europe to a certain extent. So, to sell equipment in Europe, you have to self-certify to CE. Yeah. And there are some guidelines in the machine directive, which you need to adhere to. And then also, if you claim that you adhere to 1672-2 on your declaration of conformity, then you need to adhere to that standard.
Yeah.
And, the customers could be demanding adherence to that standard.
Yeah, and I'm sure in GFSI standards, the part of your risk assessment is to look at that area and, and then it's, well, what are your references that you're working against? Matt is asking, is aluminium or aluminum acceptable in food contact?
Well, surprisingly no, because it's something that's used in pots and pans for cooking. But when it comes to a meat plant, we don't want to use aluminum. Um, and it may be safe for food contact. The problem is aluminum corrodes way too easy to be used in a meat and poultry plant, and the cleaning sanitation chemicals eat away at it pretty quickly, and then that corrosion could potentially get mixed in with the food.
Right. Okie dokie. I think that's the last question, unless I've missed any. If I have, just type it quickly. Otherwise, yeah, we've done well. Answered a lot of questions there. So yeah, appreciate your time today, Mike. Actually, there is another one, as is always the case when I'm wrapping up. Anoop, is it good to install processing plants on the ground floor or the first floor?
Well, yeah, I mean, I think most processing plants, it's a dedicated building, yeah, I mean, I've been in processing plants where they have more than one floor. I guess I could see where, from an efficiency standpoint, where it would be easier if everything was on one floor. Yeah, I guess there could be some potential increased hygienic hazards associated with having multiple floors. For example, if water on the floor above was to drain through and drip onto the equipment below, that would be a problem. So
Yeah.
it seems that a single floor would be best.
Yeah, definitely. Question from Ahumi. I visited a large catering facility that uses a large wooden table to cut large parts of cow meat into table-sized pieces. Is the use of wooden tables acceptable, considering it is absorbent and not easily cleaned and sanitized? What should be the recommended surface for cutting these raw meat?
Yeah. So yeah, wood is not an acceptable material in a meat or a poultry plant. Yeah, maybe in some types of facilities it's acceptable, but you certainly wouldn't be able to use it in a meat or poultry plant. It's very common for cutting boards to be made out of HDPE, which is a pretty common plastic. In fact, I'm sure that you could probably go to a lot of places or online, and most of the cutting boards you're going to find are made out of HDPE. So that'd be my recommendation.
Okay, thanks. And Tricia, I'm in the Rooibos industry. I have no idea what that is, excuse my ignorance. Also a question about whether materials used in food contact machine, specifically blades, they have to be magnetic to detect shavings, yet also food grade.
Yeah, okay. So I don't think they wanted to be able to be detected by a metal detector. I don't know if that means they actually need to be magnetic, but I think a metal detector does use a magnetic field of some sort. So yeah, there are exceptions. I think I mentioned in the presentation, like grinders. The blades for grinders are typically made of some harder grade of stainless that's not 300 series, probably 400 series, and it's not quite as corrosion resistant. So typically you have some additional instructions that go along with it to accommodate the cleaning and sanitation process.
Okay, very good. And a question from Jeremy. I don't know how familiar you are with BRC latest version. Would you like to comment on the implications of section 4.6 of the new issue of BRCGS standard, which puts more focus on the specification of and commissioning of new equipment?
Yeah, I'm not familiar with that standard.
But I mean, what it does do is demonstrate that what we've been talking about, that these previous question asked, will these become auditable requirements, will be integrated into, and yeah, obviously machinery and specifying and commissioning new equipment and the sanitary design of that would be implicit in that. Okay, I do think that's it. So we have got a minute or two. Mike's got to hard stop at on the hour. Any last questions? We've done really well. Yeah, first time with us today, Mike. Did you enjoy it?
Yeah, it was fun. This is a topic I enjoy talking about. So it was fun.
Excellent. Well, great presentation, great information, and lots of good questions have been answered. So all in all, fantastic. So thanks for your time today, Mike. Hope to see you again on one in the future.
Thank you, everybody, for signing in.
Cheers, Mike.
Cheers.
Okay, I'll just load your certificate in the sidebar. You'll need to print that certificate and sign it yourself, or you can open it in an image editing software such as Paint and type your name, but we can't personalize them for you because there's just too many. So we'll follow up, as mentioned, in an hour or so with the recording slides and certificate, and watch out for that email. Okay, have a nice weekend, everybody. Enjoy the rest of your Friday. Take care. Bye.